This is 1.3 part 2. So we're going to be sketching a piecewise defined function. So we're going to be graphing piecewise functions. So piecewise functions are kind of similar to graphing lines or parabolas or whatever the function may be, but it's just pieces of it. So if we look at 55 on the bottom. So here we have two pieces of our graph. So we're kind of graphing two things in one, but just pieces of each of them. Before we graph, one thing that we got to make note of, if our piecewise function has a less than or greater than sign, at that point, we have an open circle. If our graph has a less than or equal to or greater than or equal to, at that point, we have a closed circle. So only the first point is going to be that defined either open or closed circle. The rest of the points just give direction. So when we graph piecewise functions, we want to graph one piece at a time. So here we're going to start with the first piece. Now there's a couple different ways that you can graph piecewise functions. Some people graph the whole thing and then just erase what part is not needed. I like to start with where our graph starts. So this says x is less than 0. So we're only talking about x values here that are less than 0. So we're going to start with 0. So start with the number that's given. So we're going to plug that in to find what our y value is. So I'm going to do it, we'll do it on the side over here. So we have more room. 2x plus 3, I'm plugging in 0. So 2 times 0 plus 3 would be 3. So my point here, I plugged in 0 for x and got 3 for the y. So my point's going to be at 0, 3. Since it's just a less than sign, is it going to be an open or closed circle at this point? Open circle. So we put an open circle at 0, 3. We're going to stay at 0, go up 3, and put an open circle there. Now, we can't just draw our line based off of one point that we have. We need another point. So I'm going to plug in another number that satisfies this inequality. So x is less than 0. What's a number I could plug into x that is less than 0? -1. Perfect. You could have said -10 if you wanted to. Anything less than 0 will give us the direction of our graph. So I'm going to plug in -1. 2 times -1 plus 3. This would be -2 plus 3, which is 1. So I plugged in -1 and we got +1. Now the second point for this piece of our piecewise function just gives us direction. So it's not an open or closed circle here. It's just a point on our line. So we're going to go to the left to -1 and up 1. Once we have our 2 points here, we can connect our graph with a line. If you want to plug in more points just to be super sure, you can. But here, this is in the form of y equals mx plus b. So we know that it's going to be linear. So you really only need 2 points to make a straight line. So that's our first piece. We're going to do the same thing with the second piece. So we always want to start with the number that's given. So I'm going to start by plugging in 0, but I'm plugging it into my second equation now. So 3 minus 0 would be equal to 3. So I plugged in 0 and got 3. At this point, is it an open or closed circle? Closed, because we have a greater than or equal to. That equal to makes it a closed circle. So at my starting point, I put a closed circle. So we stay at 0, go up 3, put a closed circle. It overlaps with the other open point that we have, but that's fine. We're just going to put it right on top. Now for our next point, the one that gives it direction, we need to plug in a number that satisfies our inequality. So x is greater than or equal to 0. What's a number that's greater than 0? Equal to, we already plugged in 0. So what's a number that's greater than 0? 1. Sure, let's plug in 1. 3 minus 1 would be 2. So we plugged in 1 and got 2. The second point just gives us direction. So we don't put a specified open or closed circle here. It's just direction. So we're going to go to the right one and up 2. Sorry, the right one and up 2 right there. It's a straight line again because our equation here is in the form of y equals mx plus b, so it is linear. So we just connect our 2 points with a straight line. If you want to plug in more points to make it more exact, that's fine. You can plug in as many points as you want, but it's linear, so you only need 2 points to make a straight line. So that would be the graph of our piecewise function. Any questions there? All right, let's do the same thing for 57. I'm going to copy it down at the bottom just so we can see it a little bit better. All right, so with our piecewise function, we're going to do one piece at a time. So starting with the first. We're going to start by plugging in the number that it tells us. We're going to plug in 0. So I have the square root of 4 plus 0, which would be the square root of 4. What's the square root of 4? 2. So I plugged in 0 and got 2. Is my point 0, 2 going to be an open or closed circle? Open circle because it has that less than sign. There's no equal to, so we put an open circle there. So we stay at 0, go up 2, and we put an open circle. Now we need another point here to give us direction. So I don't know where my graph goes from here. I need to plug in a number to kind of see, give us an idea. So what's a number that I could plug in for x that is less than 0? Negative 2. That works. May not be the best, and I'll show you why, but let's plug in negative 2. So we have 4 minus 2 would be the square root of 2. What's the square root of 2? Can't simplify. If you know, it might be 1 point whatever. You can estimate, but let's pick a number to plug in that we know is going to give us a whole number. What number could we plug in that's less than 0? Negative 4. Negative 4 would be perfect. 4 minus 4 would be 0. What's the square root of 0? 0. So we plugged in negative 4 and got 0. The number that you plug in is your x. You're plugging it into x, so that's going to be your x in the point. What you end up with as a result, that's your y. This point just gives us direction, so it doesn't matter if it's an open or closed. It does matter, but it's not a specific open or closed circle. It's just a point on our line. So we're going to go to the left 4 and stay at 0. Could I plug in a number that is less than negative 4? What happens if I plug in negative 5? We'd get a negative. So 4 minus 5 would give us negative 1. And what did we say about the square root of a negative number yesterday? It's imaginary. So that's not on our graph. So actually our graph kind of starts at negative 4. And it has this type of curve shape. And it's going to end at that first point that we had, 0, 2. So just keep in mind when you're plugging numbers in, keep in mind your domain we talked about yesterday. Yes?
So when we draw the graph, should we do it as a straight line or do we have to do it?
So kind of like yesterday how I said it helps to know the shapes of graphs. Our square root graphs look like this, where they're kind of a little curved but end up being straighter. Just use your best estimation. Okay. If you drew this as a perfectly straight line, that would be fine. It almost looks exactly the same. So that's fine. But when we get to like parabolas and stuff, don't make something that should be curved straight, which you'll see in actually 59 is not even an example of that, but there's a couple in the homework. I'll talk about one. I might change 59 so we can see an example of it. 59 is, wait, for what? It should be a little curved, so it's got like a little bit of a curve there. But like I was saying to Grace, if you made this perfectly straight, it's almost hard to tell. So it helps to know what your graphs look like. We know that a square root graph has a little bit of a curve. So you can put a little bit of a curve to connect your points. Let's plug in our second point, or our second piece of our graph. What number am I going to plug in first? 0. We always start with the number that's given. So I have the square root of 4 minus 0 would be the square root of 4, which is 2. So we plugged in 0 and got 2. Do I have an open or closed circle here? Closed circle. So I'm going to stay at 0, go up 2, put a closed circle. The closed circle overlaps my open circle, so you almost can't even tell anymore that it was an open circle, but that's fine. It's just the way our graph looks. Now let's think. Let's be smart about the next number that we plug in. We have to plug a number in that's greater than 0. What's a good number to plug in? Let's see what happens if we plug in 5. We have 4 minus 5, which would be negative 1. So could I plug in 5? No, it does not work. So what do you think a good number to plug in would be? 4. 4 minus 4 would be 0, and the square root of 0 is 0. So we plugged in 4 and got 0. So we're going to go to our graph. We go to the right 4, stay at 0. So same thing, our graph is going to have a little bit of a curve there because our square root graphs have a little curve. And this would be our piecewise function. This would be our graph. We can't plug in anything that's greater than 4. Like Bree suggested we plug in 5. 5 doesn't work because it makes it negative. So 5 would not be in our domain here. So we have to stop our graph at 4. So you got to keep in mind when you're doing these, keep in mind your domain. All right, let's look at 59. All right, I'm actually going to change this question just to give us extra practice. I'm going to make it 2x squared minus 1. So I'm going to add a little squared to the x, just to give us some practice of graphing a parabola. Let's start with our first piece of our graph. Make it pink. What number should I plug in first? 0. Always start with the number that's given. So we have 0 plus 3 would be 3. So what would my point be? 0, 3. Perfect. Do I have an open or closed circle at this point? Closed circle. It's a less than or equal to, so we put a closed circle. So we stay at 0, go up 3, put a closed circle. Next point we need is for direction. I only have one point here. I don't know where my line's going, so I need some direction for it. So we have to plug in a number that satisfies this inequality. What's a number that is less than or equal to 0? Negative 1. That works. So negative 1 plus 3 would be 2. So we plugged in negative 1 and got 2. The second point just gives us the direction, so it doesn't have to be, it should not be an open or closed circle. It's just a point on the line. So we're going to go to the left negative 1 and up 2. We can connect our points with a straight line because we know that if it's in the form of y equals mx plus b, it is linear. This equation is linear. So it's just going to be a straight line. You only need 2 points when it's linear. Any questions with that line? All right, next let's move on to our second piece. We have 3 when x is in between 0 and 2. Here, what would we want to plug in? Where do we start? 0. Start with the numbers that are given. So we're going to plug in 0 and 2. So you always start with the numbers that are given. Do I have anywhere to plug in 0 here? No. So what's my y always going to be? What's the y? What's f of x? 3. So if I have 0 for x, what's my y? 3. If I have 2 for x, what's my y? 3. So when you have 3 pieces of a piecewise function, you want to plug in the starting number and the ending. You want to plug in both numbers that it gives you. Depending on what type of graph you have, you may want to plug in another number in between. If this was a parabola and it's got some type of curve, you might want to plug in a number in between these two to see what shape it has. But if it's just a number, what type of graph do we have? Let's plot these points and maybe we can see. At 0, 3, is it an open or closed circle? Open. And at 2, 3, is it an open or closed circle? Closed. These have specific open or closed because they are the values that are given. So only the values that are given, you want to put a specific designated open or closed circle. So at 0, 3, we put an open circle. And at 2, 3, we put a closed circle. And we connect these 2 points. If it's a flat line, what would we call this? Constant. We have a constant line here. So this is just a constant line. There's no change in between these 2 points, so we don't really need to plug in another point. It's just a number for the equation, so it's a constant flat line. Next, any questions on that one? Awesome. Next, we're going to plug in or graph our third piece. I'll make it green. So here we have 2x squared minus 1. What should the first number I plug in be? 2. We're going to start by plugging in 2. So 2 times 2 squared minus 1. 2 squared would be 4 times 2 is 8, and 8 minus 1 is 7. What did we plug in here? 2. And what did we get? 7. So our point's going to be 2 comma 7. Do we have an open or closed circle here? Open. So we're going to go to our graph. Oh, I plotted this one wrong. Went a little too far. There. We're going to go to our graph. We're going to put an open circle at 2 comma 7. So I'm going to go to the right 2 and up 7 and put an open circle. What number should I plug in next? 3. I want to plug in any number that is greater than 2. So let's plug in 3. We have 2 times 3 squared minus 1. So 3 squared would be 9. 2 times 9 is 18. And 18 minus 1 is 17. So we plugged in 3 and got 17. It's going to be way off of our graph, but that's fine. We're going to estimate. So we go to the right 3 and up 17. We'll put it way up here. What type of shape does an x squared graph have? We talked about this yesterday. What shape does an x squared graph have? Anybody know? X squared. What shape? Yes. It's a parabola. X squared, the graph is parabola shaped. So it's got a little bit of curve. So when I connect these 2 points, it's going to have some curve. Now, does my graph stop at the point 317? No, it keeps going. I could plug in 4, I could plug in 5, I can plug in 6. It keeps going. My numbers are just going to get bigger. But since it keeps going, I'm going to put an arrow there. So same thing that I did with the pink line. it didn't have an ending point. I could plug in any number less than 0, so that's why I put an arrow there. With our parabola, your graph's going to have some type of curve. So when you have x squared, here it's not super defined that it's a parabola just because it's like the upper part. It's this section of the parabola, so you can't really see the parabola shape. But sometimes you may have this section of the parabola. So if you had two numbers here that you were plugging in, you'd want to plug in a number in between to see like how low your parabola may be. So it helps to know x squared is going to be parabola shape. If you have just an x, that's going to be linear. So it would be a line. So you really only need 2 points for a line. I would suggest plugging in 3 points if you have a parabola, just because, like I said, you may have that middle part of the parabola, so you want to see how low it goes. Here we just had the upper section of it, so you can keep plugging in numbers. It's just going to get bigger, but you can plug in as many numbers as you want to get an idea of the shape. If it's constant, you only need where it's going to start and stop. And then I guess it helps to know if we have a square root graph, your graph looks like this. If you have an x cubed graph, your graph is kind of look like this, like a snake. So these are 4 common graphs that we may see, but it helps to know the shape, especially when we are graphing them.